the web page. So if I come back to the web page, I can scroll up and down, and I bet you if I add another link, like if I go to NIST and see ASSP Z244.1, there we go. American Society of Safety Professionals. Why use this standard? All that jazz is right there. And so get involved. So all of that looks good. All right, so now I have a noise gate, so you can't hear that background music that's going on. All right, so that should be, whoops, I'm streaming. I'm actually streaming. Well, let's go back to me. I was just playing with some of my, I pressed the wrong button, so I am about, I'm 11:57, I am 3 minutes early, so you're watching me set up, and I didn't even realize it. Oh well, that's the way it goes. Welcome to IAEI News Live, and I'll emphasize the live piece right there, because that's what we were. All right, well, we are live. I was fixing audio so that we couldn't hear that background, some of the background music going on. I'm just set up here on my back porch. I am taking a vacation this week, but it's always good to reconnect as part of IAEI News Live. And today's topic is going to be on Lockout, Tagout. So I'll tell you the references I've got with me. You're going to want to get your 70E book. You're going to also want to get the NEC. So all of those are going to be important for you. So bear with me while I just get things set up and connected. Go to YouTube, because I want to see some of the comments that are coming in. There it is. IAEI News Live is live. Lockout, Tagout. There we go. All right, Felix Sandoval in the house. Where are we at? So I gotta, how do I do the mute? I don't want. There we go, Costa Rica in the house. Greetings from Costa Rica. Yes, I'm in my backyard today, doing IAEI News Live. So, and I just want to let everybody know, let's see what time it is. It's 11:59. All right, we're getting set up. Make sure you got your copy of the National Electrical Code ready and ready to go. 70E, the 2021 version, is what we will be referencing for this session of IAEI News Live. So audio hopefully is coming out pretty good. Don't forget to subscribe. I don't know if I can do that. Subscribe here. I don't think so. All right. So don't forget to subscribe and hit the bell. I really appreciate that. The IAEI really appreciates that. So today's discussion, we got Michael Hofkin. Michael, I saw your note, and I know for everybody out there, in the future, we are going to be talking about those, the concept of an outline of investigation, what that is, all that jazz. I believe, Michael, that is what we were talking, and Lou Petrucci. So excellent. All right, it is 12 o'clock. All right, so welcome to IAEI News Live. My name is Thomas Dimitrovich, and today we are going to be talking about Lockout, Tagout. We're going to dig in deep, and it all starts now. Oh, hey, all right. I was setting up. I tell you, I'm like off my game here. I'm getting some red stuff, but hopefully we are doing okay. I'm not going to eat up the bandwidth. Okay, everybody. So let's talk lockout, tagout. And I'm going to get off that web page and let's talk. I just want to make sure I get all this jazz ready. Because lockout tagout is an important part of electrical safety. So when you think about lockout tagout, you should be thinking about establishing an electrically safe work condition. And what I want to do in this hour is I think that it's. So here's my thoughts on this. If you think about the national, I call it the trilogy, right? You have the National Electrical Code, which are installation requirements, and we have National Electrical Code, which is installation requirements. We have 70B on maintenance, and then you have NFPA 70E, which deals with safe work practices. Now, and the reason I like this topic of lockout tagout is because I think it really demonstrates how all three of these documents work together. Just hear me out as we navigate these waters of understanding the concepts of lockout tagout and establishing electrically safe work conditions. All right, hey Larry Griffith, thanks for joining in. And Robert from Omaha, yes, you have now reminded me. Love it. All right, so I'm gonna have to get this done because everybody seems to be having a great time outside today. In light of the definition of exposed live parts, insulated conductors, and barriers, is lockout tagout needed if not exposed? We're going to talk about that. We are going to talk about that as well. So great comment. All right, Carly Faulkner, thanks for joining us as well. And I saw your post. You said this is going to be your time to be able to join us live. So that's awesome. All right, so let's take a look and walk down through the concept of lockout tagout. It is a part of establishing an electrically safe work condition. So if we are, there's actually, if you look at NFPA 70E, there's a chapter in here. Chapter 1, establishing an electrically safe work condition, which is Article 120. Article 120 is going to be a really good and important reference for us. Establishing an electrically safe work condition. If you look at 120.1 in the 2021 version of 70E, you're going to understand that 120.1, if you just walk down through this article, establishing an electrically safe work condition is all about a lockout tagout program, which is really an important topic, and that's what this is all about today. Okay, so preventing injury to servicing and or maintenance employees due to the unexpected energization. So this is out of 29 CFR 1910.147 A3I. So preventing lockout tagout is about prevention. It's about preventing injury to servicing and or maintenance employees due to the unexpected energization or startup of machinery. So here's something I think it's important for us to understand. Lockout tagout, I know we think about this from an electrical perspective, but it's also important to think about it with regard to mechanical, like starting up equipment. There's a lot of different aspects of lockout tagout that we have to be conscious of when we're thinking about electrical safety. All right, so let's go back to our slides. So now another aspect to remember Carly, is that lockout, establishing an electrically safe work condition, I've heard people say, hey, you have to just make it safe, turn it off, and that's what you have to do. In reality, it's a lot more than just turning something on or off. There's an entire process around establishing an electrically safe work condition, and lockout tagout is just one step of controlling hazardous energy. So you've got to think about things with regard to likelihood and severity, right? You think about risk, and when you think about controlling the hazardous energy, it's more than just lockout tagout. You've got to isolate the issue. You've got to, de-energize. De-energization obviously plays an important role when we're in the electrical industry. Verification is a part of the process of establishing an electrically safe work condition, and then there's impacts of residual energy. So if you look at article, and Willie, you're right, this is for the 70E groups out there, people who are interested and try to help work through to get and meet the requirements of 70E. You really got to understand Article 120. You got to look at it from soup to nuts and understand it's more than just turning something off. Lockout tagout principles. You have control of energy. You have electrical circuit interlocks, documentation, the single line diagram. And I know I've done a program. In fact, what I'll try to do is put a link down below to the IAEI News Live session on the single line diagram. A very, very important part of establishing an electrically safe work condition is identifying all of those sources of energy. Right? You've got to understand where the energy is coming from in the power distribution system. If you're looking, especially, and it gets more complicated, think about a data center that has UPSs, all different types. Hey, we got the Philippines on. We've got excellent. So you've got to think about all the different possible sources of energy, and just think about electrical. So if you're in a data center and you've got backup UPSs, you've got probably a lot of double-ended switchgear, multiple ways to supply power to equipment because they want to increase the reliability of that installation. So when you have multiple sources, multiple options to energize a piece of equipment, as an electrical worker, as the owner, as the foreman on the job, as the designer, you need to make sure we all understand what it will take to establish an electrically safe work condition. So the single line diagram plays a very important part in this whole topic of lockout tagout. Okay, and then in 120.3 they talk lockout tagout equipment, lockout tagout procedures. Okay, they've got simple and complex. There are so many. Then there's the process for establishing and verifying an electrically safe work condition. So Article 120 is the article that you're going to be living in if you want to really understand NFPA 70E's take on lockout tagout. Willie Snyder says, I always tell my apprentices, are you locking it out at the right sources and all sources? Absolutely. Now that's the electrical side. Then you have the mechanical side. If you have, and we're going to talk a little bit about the stored energy, say from a power circuit breaker or an insulated case circuit breaker. But there are many other areas of stored energy that you have to think about, rotating equipment, and things like that. So it's really important to understand lockout tagout and the whole process of establishing an electrically safe work condition. But please don't just think about it from the perspective of turning it off. It's much more than that. Okay, so now the employer's energy control program, right? So I'm just checking on my There we go. All right. So the employer's energy control program, procedures, training, inspections. Now, the inspections can come on many different fronts. Inspections are important when you're thinking, when you think about the equipment itself, just the condition, general condition of maintenance and all this other jazz. But there's also inspections with regard to making sure your employees are following the procedures that you've laid out for establishing an electrically safe work condition. It's one thing to have the plans in place. It's another thing to have the plans in place and no one following them. So your training plays an important role in making sure all of your employees are doing what they need to be doing. And then obviously you want to make sure you're doing the right inspections for your group. All right, so I'm going to give you some reference materials. Very important, in my opinion. 29 CFR 1910. You should have a complete understanding. Somebody has to have a complete understanding of the requirements in 29 CFR 1910 because, and with regard to lockout tagout, 1910.147 is titled "The Control of Hazardous Energy Lockout Tagout." So, important document for your library. Online library, because all this stuff is available online. 29 CFR 1926, safety and health regulations for construction. So 1910 is for general industry and 1926 is for the construction industry. So 1926.417, lockout and tagging of circuits. So that's going to be an important reference for you. So here's another one, and we mentioned it already, the National Electrical Code, and here's why I mention it. There are 110.25 talks about lockable disconnecting means. Let's take a look at 110.25. All right, there it is. It's a small section. It says, if a disconnecting means is required to be lockable open elsewhere in this code, it shall be capable of being locked in the open position. The provisions for locking shall remain in place with or without the lock installed. And we're going to show you examples of that moving forward. That's going to be that's an important aspect that we're going to want to make sure that we understand. The National Electrical Code, which is why I say the trilogy. The NEC has provisions for us to provide a lockable disconnecting means. And it is used for your lockout tagout procedures. Now, it doesn't mean that the locations in the code are the only locations where you should put a lockable disconnecting means. You could put lockable disconnecting means on every single overcurrent protective device in your power system. You could put a lockable disconnecting means on every single switch in your power distribution system. Much of this is not expensive whatsoever, but it could help facilitate a proper lockout tagout procedures. So examples of provisions through the code. I give you some examples on 410 luminaires. Luminaire is a very important part of the puzzle, right? If you think about it, we do a lot of work on replacing luminaires, or what do they call those things? Replacing your lamps or relamping fixtures, all that jazz. So your luminaires, can't use fixtures anymore. So 410, Article 410 has various locations within those where you have your lockout, tagout, or your disconnecting means. And I'm just looking, I didn't highlight any of them, which is appropriate, right? So you got grounding, you got wiring. Let's go into general. Here's your general requirement. You have some definitions. You've got live parts, exposed. You have listings required for different areas. You have inspection, luminaire locations, wet and damp, in ducts, bathtubs. I'm just looking for an example of where you have a disconnect Would you say it's a risk category 1 per 70E? Open a 4 square box with insulated conductors while energized. Always someone. Well, that's a good question. Let's just take a look at some of these. I'm looking for where you might have a disconnect required, and I didn't highlight it. Anyway, we have provisions in 410. We have provisions in 422, 425, 426, 430. I know we have a requirement in 430 for providing a disconnect for motors. I'm just looking for switching requirements. Ground fault support hazardous locations. Anyway, 422, you're going to have requirements in 422 and 430. There are numerous locations in the National Electrical Code where you have requirements to provide a disconnect. And if they're required, then per 110.25, they have to be lockable disconnecting means. They have to be maintained in place even when the lock is removed. 70E, obviously, Article 120, I already talked about that. That's your article for establishing an electrically safe work condition, and lockout tagout is just one part of that big picture. 70B. So 70B is important on many different fronts. One, they have recommended practices. So in 15.8512, which 70B is moving to a standard, so keep that in mind. All your section numbers are going to probably change. But for this edition, 15.8512 says safety during maintenance and repair requires that components on which work is to be performed are electrically isolated, de-energized, grounded, and locked and tagged out. So now that's just when you're doing maintenance. Now, another aspect of 70B is when you're performing maintenance to make sure that the switch you're going to rely on, whether it be a circuit breaker or a fusible disconnect or whatever it is, that it actually isolates the circuit when you do turn it to the off position and open that switch. So you want to make sure that the equipment that you're relying on to establish an electrically safe work condition that you are going to lock and tag out does its function. And if it's not maintained, it may not perform as you intend it to. So that's another important thing to remember. Okay, now this is another document which you may or may not be aware of. ANSI, ASSP, I'll show you the webpage for this one. Z244.1, 2020, the control of hazardous energy, lockout, tagout, and alternative methods. Let's just do this. I'm going to show you, it's the American Society of Safety Professionals. All right. So that should flip for you. Lockout, tagout, and alternative methods, Z244.1. You have what is the lockout, tagout, alternative methods standard. It tells you this is their website, so ASSP.org. You can just search for Z244.1, search for the document. You can also purchase it here. I don't know how much it is. I did purchase a copy for myself. There's a podcast controlling, there's listening, there's download, hazardous energy, the battle for control in the standards arena. You can apply to be a part of the standards writing process, or if it's a Canadian, process. What is lockout tagout standard? It establishes requirements for controlling hazardous energy through lockout tagout measures and alternative methods. It explains how to apply 3 different methods: lockout, primary method, tagout, or alternative methods, to activities such as constructing, installing, repairing, adjusting, inspecting, unjamming, testing, troubleshooting, cleaning, and dismantling machines, equipment, or processes. Now, a thing to remember, lockout tagout is not just an electrical industry thing. Okay? Lockout tagout is used from many different trades when performing a lot of different types of work. So, and this standard actually, I really, let's take a look at purchase. See how much it is. I thought it was very well worth my investment as a resource. So if you are a non-member, it's $110. If you are a member, it's $95. But a great reference for you from the American Society of Safety Professionals. So you're going to want, I think you should probably put this on your list of reference materials. If that's, if you're the safety professional, if you're looking for ideas and concepts and ways to leverage or to use, you never want to go on a limb on your own. You always want to reference industry and industry materials. All right, so thank you, Lou. 410-130 G1. 410-130 G1. I knew somebody out there would 410.130 G1. Man, you would think that I would have had it bookmarked, which, you know what, I think I did, and I think it fell out. You know what, Lou? That's my story, and I'm sticking to it. 410.130 G1. G is disconnecting means. This is part 12. Special provisions for electric discharge lighting systems of 1,000 volts or less. 410.130 is general, and then G is disconnecting means, and 1 in indoor locations other than dwellings and associated accessory structures. Fluorescent luminaires that utilize double-ended lamps and contain ballast that can be serviced in place shall have a disconnecting means either internal or external to each luminaire. For existing installed luminaires without disconnecting means at the time a ballast is replaced, a disconnecting means shall be installed. Now, a lot of these are very simple items to install, not very expensive, but they get the job done. So you want those, and they talk about the location, they talk about multi-wire branch circuits. So that's just one example, and we have these in the National Electrical Code as an installation requirement for use later. A lot of the provisions, or at least some of the provisions that we put in the National Electrical Code are installation requirements not for use during installation, but for use later. All right, so that's all I have to say about that. All right, so let's go back to the PowerPoint. Manufacturer instructions. Okay, process instructions, machinery instructions. These are all very important pieces of the puzzle. Your suppliers, whether it be an electrical distribution equipment, whether it be a process, it could be it could be conveyor belt process or whatever it is for manufacturing. Maybe an organization takes a bunch of parts and pieces to put a process together for your facility from a manufacturing perspective. That manufacturer, that organization who puts that process together is going to want to provide you information that will and should be used for properly establishing electrically safe work conditions. You're going to want to look at machinery instructions. They will a lot of the machinery that your electrical workers or any worker. Remember, it's not just electrical. In my opinion, there are a lot of other reasons that you need to think about for establishing an electrically safe or doing lockout tagout. Might not be just an electrically safe. It could be a mechanically safe working condition. Lockout tagout is used for many different things. But a lot of information is coming from manufacturers of the equipment or the process. So the single line diagram, I said it earlier, and I tell you, this is, in my opinion, one of those areas that we don't focus enough. We don't spend enough time and effort to make sure that the one line diagrams are kept up to date. How can you lock and tag out a piece of equipment if you don't know all of the sources that are powering it? Like I said, data centers and those types of installations, very complicated, very complex. So, and very difficult to identify all of those areas that you need to lock and tag out. And then the verification process in addition to that. But your one-line diagram plays a very important role. Okay, so let's talk about some terminology, lockout and tagout. And I had a misconception when I first looked into the whole concept of lockout, tagout. I had a misconception that you had to lock out and you had to tag out. And they were both the same thing, but they're they're not the same. So lockout, the placing of a lock and tag or an identifiable lock on the energy isolation device. So it's the primary method of hazardous energy control. And this is out of Z244.1, which is, I think I have the 2020 edition of that, Rev 2020. So, and that's what we just went out on the website for, right? So this is their definition. And I don't believe there is a definition in NFPA 70E. Let's take a look. Lockout. Let's see if 70E defines lockout. They do not. They do not define lockout or tagout. Yet we use that terminology. Well, let's go back to the chapter. Remember, what article did we say? We said Article 120, right? So let's look at 120. Lockout tagout principles. There's lockout tagout procedures. There's nothing in 120 that defines a lockout. So Z244.1, maybe, Willie, Mr. Snyder, maybe this is an area for a public input for next cycle on 70E. All right, there's your lockout. So you have a lock, you're going to place a lock on a piece of equipment, and I know some of you are going to say, wait a second, Tom, that method is not going to remain in place when that lock is removed. So it doesn't meet the requirements in the code. But remember, there are many cases where you will use a lockout method that's not required to have a lockable means in place because it may not be required by the National Electrical Code. So there's no requirement for the lock method to remain in place when the lock is removed. So in many cases, these types of devices are perfectly legal. So remember that. Now you might say, boy, I don't know if now there's a provision where the lockout method remains in place with the circuit breaker. You could see that method would be behind the dead front on this image. Okay. But you might, and I've had in my educational materials in talking to people about lockout tagout, this picture has stirred debate. And the reason is because it's a master lock. And people say, and I've heard some individuals will tell me that they will not allow that type of a lock on their job site because there's always that one key, that can open up any lock. So the concern is, can someone else have a key for that same master lock and walk up and unlock it? And it doesn't have to be a master lock. I guess that's probably a brand. It could be any of these generic locks where anybody could have the same key. I know we've seen them. They come as part of. Here's a good example. Some people will use the dead front as a lockout method, right? And they'll take the door of the cabinet and they lock the cabinet closed, and they'll say that's locked out. But that key, I could use that same key on any one of those panel boards. So that's not a unique key for that individual. That would not be acceptable. And yes, okay, so tag is now for the identification of the owner. Robert from Omaha, yes. And in this case, this lock has a name written on the side of it. And you say, well, that's not permissible, Tom. Well, if you read the rules closely, you're allowed to do this when it's a shift, within a shift, maybe a short period of time, that type of thing. It's not something you're going to leave in place on a long period of time. So there are provisions that this could be a very a legal application. But again, you've got to follow the details of the rules. Let me just look at some of them. Would you say it's risk category 1 per 70E to open a 4-square box with insulated conductors while energized? Risk category 1. So would I say that? Well, Willie, you got to follow 70E. I mean, if you're doing a risk category 1, I don't know what you mean by risk category 1. You're talking about an arc flash PPE category 1? What section of the 70E are you talking about from a risk category. I mean, if there is, if it's an exposed conductor, you have the risk of shock, period. If it is, if you are talking arc flash PPE category, then you're going to look at the enclosure. If you're using the table method, you're going to do 130.7 Charlie 15A, and you're going to follow those procedures. So, Mr. Snyder, I'm not sure what risk. Give me a reference when you talk about a risk category. 1. Help me understand the category. What section are you talking about with regard to a risk category? I would love to. I can answer that question, but I need more information from you. Okay, so then there's group lockout. ANSI Z244.1 and 70E does not define group lockout either, although I believe we referenced that in Article 120. You have the tagout device, you have tagout procedures, you have lockout devices. Only one circuit per piece of equipment is de-energized. Employees exposed to hazard. Each employer shall supply employees with a lockout tagout device equipment necessary to execute requirements of 120.3, locks and tags. Identifiable lockout tagout device should meet the following either key or combination. Shall be included method of identifying the individual. A lockout device shall be permitted to be only a lock. Okay. Lockout device should be suitable for the environment. Tagout devices, lockout tagout procedures, planning and location. They have complex, multiple energy sources, multiple crews, so you have your complex lockout tagout procedures. All right, so you have your group lockout, and this is what we mean by group lockout. So in this case here, multiple locks can be placed. So in the case of our company policy is to not open any boxes energized, which I disagree with, because how can you test for the absence of voltage? So, Willie Snyder, your company policy is to not open any boxes energized. Well, I would say a couple things. That's a good point. And here's what you're saying. So here is what Mr. Snyder is saying. Okay. What you're saying is your policy says you can't open a box energized. Yet, you have to assume it is energized until you verify absence of voltage. So even if you go through a lockout tagout procedures and you're going to go back to the overcurrent protection, you're going to come back to the switch or the circuit breaker, and you're going to lock and tag it out, and then you're going to go over to the box and you're going to open it. But when you open it, you need to then verify absence of voltage. So I see your point. What you're saying is that you have to verify absence of voltage before you can actually say it is de-energized, and you can't open the enclosure. So your policies probably could be a little clearer to the electrical worker to say, instead of saying that you can't open any boxes that are energized, you could say boxes can be opened after an electrically safe work condition or during the process of establishing an electrically safe work condition, right? So it probably could be written better, to your point. So it's not a bad comment. But I think you get where your employer is going. They don't want you exposed. You could install a test port. And Robert from Omaha, you're saying, why would you open it? Why would you open the box? Well, you could be, to Mr. Snyder's point, you could be troubleshooting. In that case, you would have to have exposed energized parts. If you're troubleshooting, to say measure voltage at that point for whatever reason. And I'm not going to hazard a guess on what the reason would be that you would have to open up that junction box. A company not to open any boxes energized. And a box, I don't know what you mean by box. A panel board could be a box. I mean, depends on what's your definition of a box. You can use no contact measurement instruments. So Felix, you got to be very careful using no contact measurement the types of devices. You can use it as a part of the process, but you should always use a proper tester. All right, let's continue. Lockout device. So let's talk about a lockout device. What was our first one? The first one was a lockout, just a lockout. But then we have a lockout device. Again, I'm going to 244. And that's how I found Z244, was because I was trying to find what is a good definition of these, what's a good definition of a lockout device. There are no definitions in 70E for what a lockout device is. It's just, I say that, I'm going to look now. There's nothing here, nothing that says lockout. Let's look at device. Look at device, and then maybe there's a device lockout. No. Device is a unit of electrical system, but there's no lockout. So these terms aren't found in 70E, so you got to go elsewhere. NCZ 244 tells us a positive means, such as a lock, for individual control that secures an energy isolating device in a position that prevents the energizing of a machine, equipment, or process. This includes devices such as accessories to go over valves and other isolating devices. Oh, that's another good point. So I could have a lockout device which could go over the cover of a panel board and make it so that I can't get access to the overcurrent devices which are in the off position unless I have the right keys. All right. Could be a shared neutral. Yeah. And you're right, Robert. All right. I'm loving the discussion. Get that chat going. That's what this is all about. We learn from each other. Thanks for chatting it up. Okay. A lockout device includes a lock, either a keyed or combination, includes a method of identifying the individual who installed the lockout device. It is permitted to only be a lock, and I showed you that picture. And you have to meet conditions. If it's just the lock, if the lock is readily identifiable as a lockout device, and it has to have a means of identifying the person who installed the lock, and it's provided that all of the following conditions exist. Only one circuit or piece of equipment is de-energized. The lockout period doesn't extend beyond the work shift, and the employees exposed to the hazards associated with re-energizing the circuit or equipment are familiar with the procedure. So that picture that I had earlier that showed a lock with a person's name on it is permitted, but you have restrictions. So, and these are those restrictions. You got to be very mindful of that. Okay, continuing on. What are other lockout devices? This is in 120.3c. Okay, the lockout device has to be attached to prevent operation of the disconnecting means without resorting to undue force for the use of tools or the use of tools. Now, you could use a tag in conjunction with a lockout device, but the tag shall contain a statement prohibiting unauthorized operation of the disconnecting means or unauthorized removal of the device. The lockout device has to be suitable for the environment and for the duration of the lockout. Whether keyed or combinations are used, the key or combination shall remain in the possession of the individual installing the lock or the person in charge, and when provided by the established procedure. So that's another important aspect to remember for that key. And then the combination. So I've had those questions in the past. Can I use a combination lock? You can. I personally like the physical key a lot better, but that's personal preference. You can do however you want, as long as you follow these rules. Okay. Lockout devices shall be suitable for the environment. Remember, you might have these in wet locations or in outdoors. So you have to make sure that the or corrosive environments, they have to be manufactured from a material that will withstand the effects of the corrosive material. So, or the corrosive environment, actually, I would say. So remember that. Okay. Shall be attached. Where the tag is used, we already talked about those. Already talked about that. Locks used to secure an energy isolating device must be standardized within the facility. They must all be the same size, shape, or color so that they will be more easily recognized as lockout devices used for employee protection. What this is trying to avoid, it is trying to avoid using locks that, I don't know, you might have locks on lockers for your employees. Those locks aren't the same locks that you would use in your lockout tagout. You want these to be separate. You want them to be identifiable. You want them to be recognized as being special for that specific application. I think that's a big or a very important piece of the whole process. Singularly identified means you should be able to look at a lock and determine exactly who applied that device. You can firmly attach a durable tag with your name. You could plot a sticker with your name on the lock. You can engrave your name on the lock. You can have your special, Robert, you probably have your golden locks in that you use that have your in diamonds your name on the side of them. That's what you call it. That's called lockout tagout bling. Okay. You can have a log to identify the person using a lock with a particular serial number or similar identifier. So all of your locks could have serial numbers, and as long as you have a document somewhere that says these serial numbers are for this employee, you'll meet these requirements. They must be used for no other purpose. They are for securing energy control devices only, so do not use them for locking doors, your toolboxes, gates, or any other purposes. Remember, you want these are special locks, so keep them special. Some examples. So there's that master lock again, and every time I show a picture like this, I'll get somebody in the audience who will say they will not allow these types of locks because if those locks might be used for other reasons within their facility, to lock gates, to lock toolboxes and things of that nature. So, and again, you have to look at your policies, your procedures, and make sure they adhere to your policies and procedures and the requirements of 70E. But the other nice thing about these images here, these methods to lock remain in place after the lock is removed, so they would meet the requirements of the National Electrical Code whenever the provisions are in place that says you need to be able to lock and tag these need to be lockable in the open position, and then 110 tells us that those provisions have to remain in place. Your lockbox, a container typically used, again, this is Z244, typically used in group lockout that secures all your keys to locks on secured energy isolating devices. So this is what they'll probably look. You'll see these safety lockout centers in facilities where they have all of the locks in place. They'll have the keys, and they have, like what we have here is the lockout tagout manuals and procedures for the workers in the facility. So Mr. Snyder says he has a master style lock, but it's in combination with a larger lockout program, and we use a one key system. So there's a way. So Mr. Willie, that's a very good point that there are ways to make these locks special. So I think the important part of the whole puzzle is what you're saying there. You have it a part of a program. Very important. Tagout. So this is a means to prevent the inadvertent re-energization of machinery or equipment using a tag, securely fastened to an energy isolating device. Now, this is a less preferred method of controlling hazardous energy, but it is a permitted method to control hazardous energy. And Z244 it talks about this in depth. Now, the Tagout device has a tag, readily identifiable as a Tagout device and suitable for the environment, durable and duration of the Tagout. The attachment means, so 50 pounds of force exerted at a right angle to the disconnecting means surface. The tag attachment means shall be non-reusable, attached by hand, self-locking, non-releasable, and equal to an all-environmental tolerant nylon cable tie. So those little, and I just used them to tie up. I just made a what do you call this? A little battery station in my garage this week, where I put all of my chargers, and I made a little shelf, and I tie wrapped all of that stuff up using a method that is permitted for lockout tagout. So as long as you meet these, you can tag out. So you can lock out or you can tag out. They have to contain a statement prohibiting unauthorized operation of the disconnecting means or removal of the tag. A hold card tagging tool on an overhead conductor in conjunction with a hotline tool to install the tagout device safely on a disconnect that is isolated from the work shall be permitted. Where a hold card is used, the tagout procedure shall include the method of accounting for the personnel. So this is 70E 120.3 Charlie. So here is a tagout. So indicate that the energy isolating device equipment being controlled cannot be operated. So and there's your tie wrap, right? That meets the restrictions from the force perspective. You have a do not operate. You have the warning that says this tag and lock to be removed only by persons shown on back. So, and these are all of your 1910-147 section references. It meets the requirements of 70E. It meets the requirements of OSHA. Is it the preferred method? No, but it is an acceptable method. None of these methods protects against criminal malice. Oh, that's true. That is true. Absolutely right. So, Mr. Snyder, do you guys use this method? Have you seen this method used, just to tag out and no lock? I'm curious to hear your thoughts on that one. Doug Daniels, install the test port. We got Lou Petrucci, Carly Faulkner. All right, let's keep going. All right. In certain regulated industries, railroad, nuclear, maritime, utilities, tagout is used to achieve an equivalent level of lockout. In some process environments, a combination of lockout and tagout is used to achieve hazardous energy control. Now, I see railroad, nuclear, maritime, so let's take a look at what's the scope of 70E. 70E does not cover ships, watercraft, or other floating vehicles, railway, rolling stock, aircraft, or automotive vehicles, other than mobile homes and recreational vehicles. Installations of railways for generation, transformation, transmission, distribution of power. Installations on the exclusive control of the electric utility. So, and I find that this is out of Z244, where they're talking about tagout achieving an equivalent level of lockout, and they're highlighting areas where they're not really covered by 70E. All right, so 70E 110.5L. What's 110? 110 is your general safety, electrical safety related work practices. 110.5. Electrical safety program, and L, this is your electrical safety program. L is lockout tagout. The electrical safety program shall include the information required by one of the following: a lockout tagout program in accordance with 120.1A, a reference to the employer's lockout tagout program established in accordance with 120.1A. All right, so one, you have to understand your priorities. Life flight, going to the hospital. Say a prayer. So understand your priorities. Hazard elimination shall be the first priority in the implementation of safety-related work practices, and this is 110.1. Now, 110.1, this was a recent change, I believe, in the 2021 edition. They wanted to make sure that hazard elimination is priority one. So that's understand what your priorities are. 110.1, 110.4 says energized work. This is your additional hazards of infeasibility, equipment operating less than 50 volts. So recognize that all hazard elimination may not be feasible. So what we're trying to say here is, we understand, and I think we've talked about it a little bit in the chat. You have to establish an electrically safe work condition, but again, it might not always be feasible. Recognize the electrical hazards. 70E, Article 100, you have to understand look at the definition of what an electrical hazard is. 110.2 talks about your electrical conductors and circuit parts shall not be considered to be an electrically safe work condition until all of the requirements of 120 have been met. So everything in Article 120 have to be met. Safe work practices applicable to the circuit voltage and energy levels shall be used in accordance with 110 and 130 until such time that the electrical conductors and circuit parts are in an electrically safe work condition. So all of these sections that you see here are important to help you recognize the electrical hazard. Arc flash. You've got to recognize, cannot play media. Arc flash events can occur. Electrically safe work condition. Electrical conductors and circuit parts operating at voltages equal to or greater than 50 volts. This is 110.3. 50 volts is a threshold. That's a number you need to be aware of. But then you also have to identify and understand the equipment that you're looking at. You might look at a piece of equipment and think, hey, there's nothing in here that could possibly be more than 50 volts. But if you don't understand that equipment, then you really can't tell what is whether or not you have a hazard there. The presence of an energy source alone does not by itself warrant the need for energy control. The risk assessment process has to determine which energy sources are considered hazardous for each task. Energy sources that do not present a hazard or exposure to the hazard do not require control of hazardous energies or alternative methods. So your tasks are going to be important. This is out of Z244. Okay, so understand the equipment, understand the work that you're going to be performing, and then understand whether or not that there's any exposure there. And that's all a part of a qualified person, right? That individual who's going to be performing the work, if that person doesn't understand the equipment they're going to be working on, then they're not qualified to do that work. I'm seeing chats. Forget to take the lock off the master block at the end of the day and walk the walk of shame in the morning and get chewed out. Yes. 3 or 4 signs on the road leaving plan. Did you remember to remove your lock if you forgot? That's there's a procedure. Now there is a method that they can remove a lock if you are, say you go home and you go on vacation and you forgot to remove your locks. There are methods and procedures, and they're outlined in Z244 where that lock can be removed, but they've got to follow the right procedures. Get a hold of the person who put it on there, and follow up in writing, all this good stuff. So there are ways to get that done. So you may not have to go back into work, but there are methods that you can employ, but you got to make sure you do them correctly. Short circuit current ratings. When you exceed the short circuit current rating of a piece of equipment, the fault is not in the equipment, it's downstream and too much current passed through it. Now, here's my issue. Here's the point here. This is why the requirements, you saw a lot of requirements, and you keep seeing a lot of requirements around proper application of overcurrent devices, proper application of interrupting ratings, short circuit current ratings in the National Electrical Code. That plays an important role in understanding the hazards. So National Electrical Code 70B, SCCR, interrupting ratings, voltage ratings, ampacity values, conditions of use, maintenance, all play a role in the proper application and your safety-related work practices. So recognize the hazards. You might look at a piece of equipment like this. It's not a simple, this isn't simple equipment. These are very complicated equipment that if you don't understand what's in there, you don't know if you're performing the right lockout tagouts. You have stored energy, such as rotating equipment. You have very complicated, again, distribution equipment. You have to sit down and say, if you don't know what all of that equipment is and what voltages are present, you don't know what overcurrent devices to turn off, you're not qualified for that application. All of these are good examples of performing the right that are important to the process of establishing an electrically safe work condition, which, again, lockout tagout plays a part of that. Chemical and procedural approaches can differ. So all your equipment, all of your procedures in different facilities could be different. Less than 50 volts, normal operating condition. Is it feasible? What is the work that you're going to be performing? Shall not be considered to be an electrically safe work condition until all the requirements of Article 120 have been met. We already read that. Lockout program principles, equipment, procedures. 120.2, lockout tagout principles, employees' involvement, procedures, your control of energy, your electrical circuit interlocks, your control devices, identification, coordination. All of these are important parts of the principles around 120.4. Yeah, burns or ignition, not just shock. That's exactly right. You've got to think about all of the aspects of the hazards involved. All right, locating your sources, exposing who's going to be exposed, who's the person in charge, simple versus complex, 120.4. All of the elements of control have to be in place. It's not just lock and tag out. You have to verify. You have to de-energize the equipment. You have to release all stored energy. And I want to touch stored energy. I know it's coming to the end here. So let me just find. Here we go. Lockout tagout procedures. Let's talk about this. Now, what you'll see on some of these circuit breakers, when there's that charging arm. Look at this, what you're seeing over here, you have discharged. You might be in a state where it is charged. Discharged is what you're looking for. You have that button that you're going to place a lock and a tagout on. You've got to make sure that you have the right pieces and parts on place. I would not unlock with your smartphone. Here's the thing, Robert, a lot of these that are remotely operated have provisions to make sure that you do not lock, that you can't remotely open or close these. Now, hopefully you'll be able to hear this one. It's mic aux. Let me just add another one here. Hold on. Audio input. I'm going to do audio capture. I'm going to say computer. I just want to make sure you, I believe this is going to be MacBook Pro microphone. So let's try something here. Whoop. I'm going to just try something here and see if you can hear this.
Springs must be mechanically charged, either manual, via this motor that looks like a drill motor. Opening springs charge with the motion of closing.
I want to play that one again for you.
Springs must be mechanically charged, either manual, via this motor that looks like a drill motor. Opening springs charge with the motion of closing.
All right, so that is, yeah, Willie, you know what? These guys never cut their grass ever, and they decide to do it at noon during a work week. So I don't get it. I don't get it. Okay, identify the machine, equipment, or procedure listing. All right, hopefully it's not that bad. There we go. Maybe this is a little bit better. I don't know. We're gonna try this. You gotta love it. You gotta love it. Okay, so identification of the machine or equipment or process. Hey, Joseph Violi, thank you for joining in. Lock removal. Here's what I was talking about. The work area shall be inspected to ensure that non-essential items have been removed, the machine, equipment. This is before you return to service. So, you know, establishing an electrically safe work condition is one part of it, but then also when you're done, the other aspect of it is getting back into service. Non-essential items have been removed. The machine, equipment, or process is operationally intact. All controls are in a neutral or safe position. Each person is in a safe location. The affected persons have to be alerted before the hazardous energy is restored to the machine, equipment, or process. Each lockout or tagout device has to be removed. Each lockout and tagout device shall be removed from each energy isolating device. So there is a definite process. I don't know how I did that. All right, so there we go. Ventured out into the man. Sorry about that. I was muted. Okay, so hopefully you have all of that information and you know how to establish an electrically safe work condition. Lockout, tagout is an important part of establishing the electrically safe work condition, and then you have to think about restoring it back to its normal place. So in normal condition operating procedures. Follow all of those rules. Hopefully the sections that I gave you, the reference materials that you got were adequate and helpful for you. So thank you for tuning in. Willie Snyder, Robert from Omaha, Joseph Violi. Hey, better late than never. That's what I always say. Willie Snyder, Doug Daniels, everybody out there, thanks for what you do for the electrical industry. Thanks for what you do for electrical safety. Remember to stay safe and please stay healthy. See you next week.